if you look around the room you are currently sitting in, or look out the window if you happen to be on a train or in a car, you naturally perceive the space around you as a sort of empty, rigid box.
Right. It feels like a very passive stage.
Exactly. You are the actor, the objects around you are the props, and space is just the void in which the events of your life play out.
And time, similarly, feels like a uniform ticking clock in the background, entirely indifferent to what you are actually doing.
We carry this fundamental assumption every single day. But consider the possibility that this stage is not an empty box at all.
I mean, consider that space and time might be a fluid, deeply creative structure.
Yes, a medium that is actively shaping everything, from the gravity, keeping your feet on the ground, to the very mechanics of biological evolution.
It is a massive conceptual leap.
It really is. So, welcome to this deep dive. Our focus today is tracing the evolution of this exact worldview through pages of Jan Smuts' 1926 philosophical treatise, Holism and Evolution.
Specifically, we are diving into a rigorous closer reading of Chapter 2, titled The Reformed Concepts of Space and Time.
And it requires a profound shift in perspective to grasp what Smuts is attempting in this chapter.
It absolutely does. We are going to anchor the vast majority of our discussion, I'd say about 80%, in the pristine original text published in 1926.
Right, isolating the philosophical mechanics of his argument.
Exactly. However, a text like this is a living document, and the physical ink on the page did not remain static. So for the remaining 20% of our deep dive, we will examine the variorum.
The specific alterations he made later on.
Yes, the nuanced and sometimes really startling alterations Smuts made in the 1927 and 1936 editions. Tracking those specific changes across a decade exposes this intense friction.
Friction between what? Exactly.
Between Smuts' initial philosophical audacity and his subsequent intellectual accommodations to the rapidly solidifying scientific establishment of the early 20th century.
That tension is going to be central to our understanding of the text. To really grasp the gravity of Smuts' project, we have to start where he starts, which is not with a new theory, but with the autopsy of an old one.
He opens Chapter 2 by diagnosing the breakdown of what he calls Victorian fixity.
Yes, he asserts that the Victorian scientific worldview, which basically dominated the 19th century, was defined by hard and narrow conceptions and fixed counters of thought.
That specific phrasing, hard and narrow, is doing a lot of structural work right out of the gate.
How so?
Well, it establishes the precise philosophical target he intends to dismantle. When he describes the Victorian framework as hard, he is referring to a universe conceived as rigid, unyielding, and entirely mechanical.
A system closed off to fundamental novelty or structural evolution.
Precisely. And narrow, on the other hand, suggests a conceptual apparatus that was adequate for a very limited local range of phenomena.
Like the immediate mechanics of the solar system, or maybe the behavior of terrestrial machines.
Right, but completely insufficient for the grander cosmic or microscopic scales that were just beginning to emerge in science.
So Smuts argues that a conceptual revolution, which initially took root in the organic sciences, has decisively extended into the domain of the inorganic.
The old rigid order isn't just under review, it is actively dissolving.
And to describe that dissolution, Smuts deploys a highly specific, very evocative metaphor. He writes that the fixity of the atom has followed that of species into the limbo of the obsolete.
We really need to pause on limbo of the obsolete. That is not standard scientific terminology.
No, it's a distinctly theological metaphor, just inserted right into a text about theoretical physics and biology.
The invocation of limbo is mathematically precise in its metaphorical intent, though. In classical theological architecture, limbo is a border realm.
It's the edge of hell.
Right. It represents a state of suspension for souls that do not warrant damnation, but they are denied the beatific vision. They are stuck.
So by arguing that the fixed atom and the immutable species have been relegated to the limbo of the obsolete, Smuts is capturing their exact epistemological status in 1926.
Yes. They inhabit a boundary zone. They are formally acknowledged as errors by the vanguard of theoretical physics and evolutionary biology.
Yet they haven't been entirely abandoned by the general public.
Or even by the older generation of scientists. They linger stubbornly in the cultural and educational consciousness, dead but unburied.
Historically, mapping that transition requires looking at the milestones of that obsolescence. To anchor this argument about the breakdown of fixity, Smuts points the reader to 3 specific years that stand out in bold relief across the intellectual landscape.
Let's lay those out.
He gives us 1859, which is the publication of Darwin's Origin of Species. He gives us 1896, which is Henri Becquerel's discovery of radioactivity. And he gives us 1915, the publication of Einstein's general theory of relativity.
A very deliberate triad.
But evaluating that timeline from a modern perspective, 1859 is the undeniable turning point for biology. And 1915 is the undeniable turning point for gravity and space-time.
I see where you're going with this.
For physics, pinning the revolution to 1896 is an intriguing choice. If you are trying to mark the death of classical Victorian physics, one might naturally expect Max Planck's introduction of quantum theory in 1900.
Or perhaps Einstein's special relativity in 1905.
Exactly. So why does Smuts deliberately select Becquerel in 1896?
The selection of 1896 reveals the core architecture of Smuts's overarching argument across the entire book. He's not merely charting a generic history of physics.
He's a very specific agenda.
He does. He is establishing a structural parallel between the organic and the inorganic realms. Becquerel's discovery of radioactivity demonstrated empirically that the elements themselves decay.
It proved the transmutation of atoms.
Yes. Prior to 1896, the atom was defined conceptually as the indivisible, eternal, unchangeable building block of the material universe.
It was the ultimate fixed concept.
And radioactivity shattered that immutability. It showed that atoms have a lifespan, a history, and a capacity for spontaneous transformation.
Which mirrors Darwin perfectly.
Exactly. Just as Darwin proved that biological species are not eternal, fixed categories, Becquerel proved that the physical elements are not fixed either.
So Smuts is establishing that fixity itself is a fundamental category error when applied to any layer of our dynamic universe.
That is the crucial takeaway. He uses Becquerel to demonstrate that matter itself is engaged in a fluid, creative process.
And this sets the stage perfectly for his demand that our concepts of space and time must also shed their Victorian fixity, which leads him to pivot directly to Einstein's special relativity to dismantle the old Newtonian framework.
The foundational premise he extracts from special relativity is incredibly disruptive to our daily experience. It's the idea that the subjective feeling we all have of being at rest is a pure illusion.
Right. The recognition that motion is never absolute is the germ of relativity mechanics. Smuts is very careful to articulate this. We naturally operate under the assumption that our immediate environment, the room, the chair, the ground beneath our feet, is stationary.
But that is merely a local, relative observation. A point on the Earth is rotating around the planet's axis.
And the Earth itself is tracing an elliptical orbit around the Sun.
The solar system is moving in relation to the local star cluster, which is rotating around the galactic center. There is simply no ultimate, privileged, stationary point of reference anywhere in the physical universe.
Consequently, any assertion of rest, or any measurement taken from a presumed state of absolute rest, is inherently flawed if we attempt to project it universally.
Now, to make this abstract concept of relative motion concrete, and to show how it actively distorts our baseline measurements of reality, Smuts leans on a specific phenomenological thought experiment.
He utilizes a variation of Einstein's famous moving train scenario.
For you listening right now, try to visualize this setup clearly because the mechanics of it are crucial for understanding the rest of the chapter.
Imagine you are standing perfectly still on a railway platform. A train goes speeding past you. Now imagine a second observer who is driving a motor car on a road parallel to the tracks, moving in the same direction as the train, but at a different speed.
So we have multiple observers, all in different states of relative motion, trying to measure the exact same physical event, the passage of that train.
When mathematical physicists apply the equations of special relativity to this exact scenario of moving observers, they arrived at results that completely violate our everyday Newtonian intuition.
The observer in the motor car and the stationary observer on the platform will not agree on the physical dimensions of the train.
Which sounds absurd at first.
It does. But specifically, to an observer moving relative to the train appears mathematically shorter in the direction of its motion than it would appear to someone standing still.
This phenomenon is known as length contraction.
Furthermore, the duration of time it takes for a specific event to happen on that train, say the ticking of a clock visible through the window, will appear to take longer for the stationary observer than for someone moving along with it.
And this is time dilation.
Yes. The physical measurements of space and time are not universal constants. They are entirely dependent on the relative state of motion of the observer taking the measurement.
The natural assumption, if you hear that your clock is ticking differently than my clock, is that one of our clocks is simply broken.
But Smuts makes it undeniably clear this is not mechanical error. It is a fundamental property of reality.
And he points out a specific structural relationship between these two distortions. Space and time do not just warp randomly depending on how fast you are moving. They vary jointly, but in perfectly opposite directions.
That coupled variation is the vital mechanism Smuts wants the reader to understand. As the spatial dimension of a moving body appears to contract along the axis of motion, its temporal dimension appears to expand.
They vary in strict inverse proportion according to the velocity of the system.
The underlying physical mandate requiring this joint variation is the invariance of the speed of light.
This is a critical point.
It is the anchor. The speed of light in a vacuum must remain absolutely constant across all frames of reference, regardless of how fast an observer is moving toward or away from the light source.
In order to preserve that universal constant, space and time must fluidly adjust themselves.
The contraction of the measuring rod and the slowing of the clock neutralize the differing velocities of the observers. Space and time literally yield to ensure light remains the invariable constant.
Because space and time are locked in this inverse, compensatory dance, always adjusting together to protect the speed of light, Smuts argues this necessitates a complete conceptual overhaul.
They cannot be separate entities.
Which leads him to introduce Hermann Minkowski's 1908 formulation, the space-time continuum.
Minkowski recognized the profound mathematical and philosophical implications of this coupled variation. If space and time systematically and inevitably compensate for each other in every natural event, they cannot be independent, isolated factors of reality.
To represent the physical universe accurately in mathematical terms, time must be integrated as a coordinate axis.
It is introduced as a fourth dimension, and importantly, it is not a fourth spatial dimension.
Right, we are not talking about hypercubes or esoteric geometry.
No, rather, it's a dimension of a unified, singular space-time continuum. Smuts seizes on this to declare that the notion of separate, purely spatial extension or separate, purely temporal duration are mere abstractions of the human mind.
In the actual occurrence of physical events, they are found exclusively in separable conjoint action.
Before we dig into the philosophical proof of that inseparability, I think it's necessary to address how Smuts expects his audience to process this dense information.
He does acknowledge that the mathematical processes Einstein and Minkowski used, tensor calculus, non-Euclidean geometry, are incredibly difficult.
To navigate this, Smuts offers an analogy about a tunnel.
It is worth modernizing that slightly for clarity.
Yeah.
Imagine you are riding a subway system deep underground in a foreign city. You don't know the engineering of the tunnels, you don't understand the electrical grid powering the rails, and you don't know the exact coordinates of the bedrock you are traveling through.
You're completely in the dark regarding the technical mechanics.
Exactly. But when you finally emerge from the station, walk up the stairs, and step out into the sunlight of the city square, you can clearly see the architecture, the layout of the streets, and how the city functions. You possess a clear viewpoint of the reality above ground.
And you don't need to plunge back into the darkness of the subway tunnels to validate the sunlight.
Smuts is arguing that we do not need to master the obscure, dark tunnels of tensor calculus to comprehend and utilize the clear philosophical daylight of the space-time continuum.
That methodological distinction is critical for establishing Smuts's authority in the text. He's differentiating between the technical mathematical apparatus, which belongs to the specialist, and the overarching philosophical viewpoint, which belongs to the philosopher and the general intellect.
Having used the empirical facts of special relativity to bring us out of the tunnel and into the daylight, he then constructs a purely conceptual philosophical argument to prove why space and time must be inseparable.
He calls this his mutual necessity argument, and it operates entirely independent of the mathematical physics.
Let's examine the mechanics of that mutual necessity argument. If we strip away the physics and just look at the raw concepts, how does Smuts logically bind space and time together?
He begins by isolating the core characteristic of time, which he defines as succession, or the time series. He then isolates the core characteristic of space, which he defines as coexistence, or the space series.
Okay, succession and coexistence.
Smuts posits that succession time would perish at every single step if it did not possess coexistence space in which to endure.
That's a dense logical step. Let's unpack that.
If time were entirely composed of pure succession, devoid of any spatial persistence, Each fraction of a moment would simply vanish into absolute nothingness the instant it occurred.
Because there's nowhere for it to exist.
Exactly. A series could never form because there would be no enduring background against which transition could be registered. There must be a spatial persistence that endures through the temporal transition.
So without space, time just blinks out of existence instantly. What about the inverse? How does space require time?
Conversely, coexistence, which is spatial extension, would remain frozen at its very first point of origin if it lacked succession.
Space cannot be spread out.
It cannot be traversed, and its extension cannot be comprehended or realized without the movement of time to measure it. To possess extension fundamentally requires movement through time to encompass that extension.
Therefore, the very concepts interpenetrate each other at their root. They are logically unintelligible when isolated. You cannot formulate a coherent thought about space without implying time, and vice versa.
That conceptual interpenetration sets up the next major physical leap in the chapter.
Because special relativity, with its flat space-time and constant speeds, was really only the first step.
Einstein recognized that the real universe is not filled with objects moving in perfectly straight lines at uniform velocities. The universe is filled with acceleration, rotation, and changing speeds.
So, to apply the space-time continuum to the actual messy universe, Einstein developed general relativity. And this leads us to what Smuts considers a monumental achievement, the geometrization of gravity.
To explain this, Smuts turns to a thought experiment that he audaciously predicts will become as historic as Newton's falling apple.
The closed cage in distant space.
Yes. The closed cage scenario is the pedagogical tool designed to illustrate the equivalence principle, which is the beating heart of general relativity.
Smuts instructs us to imagine a man enclosed in a sealed cage, floating in distant empty space, completely isolated from the gravitational influence of any planet or star.
The observer inside has no windows and no way to visually reference the outside universe. Now, suppose an external mechanism begins to draw this cage upward, with a constant, unvarying force causing the cage to move faster and faster.
From an external objective standpoint, this is a scenario of pure, unadulterated physical acceleration.
But the observer inside the cage experiences a completely different reality. Because the floor of the cage is accelerating upward into him, he feels a downward pressure.
He feels exactly as though he's being pulled down by his own body weight.
If he takes an object, a pocket watch, a coin, anything, and releases it from his hand, the floor of the accelerating cage rushes up to meet the object.
To the observer, it appears exactly as though the object is falling to the floor under the influence of Earth's gravity.
The defining element of this thought experiment is the universality of that falling motion. Smuts emphasizes a very specific, crucial detail here.
What is that?
The rate at which the object appears to drop to the floor of the cage is perfectly identical regardless of the object's mass, figure, size, or material composition.
A lead weight and a feather will hit the floor simultaneously in this vacuum cage.
Simply because the floor is accelerating upward at a uniform rate to meet them both. This universality of free fall, where all bodies fall at the exact same rate, is the definitive, unique signature of gravitation.
Because the observer inside the cage witnesses this universal rate of fall, he will inevitably and logically conclude that the cage is resting in a gravitational field.
The physical reality is pure acceleration, but the internal phenomenological experience is pure gravitation. They are indistinguishable from inside the box.
That indistinguishability is the profound conclusion. Smuts stresses Einstein's realization that acceleration and gravitation are not merely similar. They are exactly the same phenomena described from different reference frames.
They are mathematically and physically equivalent expressions. No local measurement inside that cage could ever determine whether the phenomena are caused by a massive planet below or an accelerating engine above.
If we accept that acceleration and gravitation are fundamentally equivalent, Smuts then takes us to a specific form of acceleration: rotation.
He introduces the rotating disk experiment to demonstrate what this equivalence actually does to the geometry of space. And this is where the classical Newtonian worldview shatters completely.
The rotating disk experiment requires careful visualization.
Imagine a large, perfectly circular disk revolving steadily around its center. An observer is positioned on this disk, equipped with two identical, perfectly synchronized clocks.
The observer places one clock very close to the center of the disk and places the second clock on the extreme outer edge, the circumference.
Because the disk is rotating, the physical velocity of a point on the outer edge is much higher than the velocity of a point near the center. The edge has to cover more distance in the same rotation.
Applying the principle of time dilation we discussed earlier regarding the moving train, the observer will discover that the clock on the fast-moving outer edge ticks differently than the clock near the slow-moving center.
The immediate consequence is that time on this disk is no longer uniform. It varies dynamically depending on your spatial distance from the center.
But the distortion isn't limited to the ticking of the clocks. The observer also brings identical, rigid measuring rods to measure the surface of the disk. What happens to the spatial dimensions?
When the observer places a measuring rod along the fast-moving circumference, the rod is subjected to the length contraction inherent in special relativity.
The rod on the edge physically appears shorter than an identical rod placed near the center.
Consequently, because the measuring rods are continually changing length depending on where they are placed on the disk, they will measure out differing amounts of space. The spatial dimensions on the disk are not consistent in all directions.
To the observer attempting to map this area, the space itself appears twisted, warped, and uneven.
The critical universe-altering deduction here is that the space of the rotating disk is absolutely not the straight line, homogeneous, uniform Euclidean space we learn about in high school geometry.
It is intrinsically curved and non-Euclidean.
Yes. When you combine the varying time and the varying space, the disk represents a non-Euclidean space-time continuum.
This requires a major logical pivot to connect it back to planets and stars. If rotation is simply a form of acceleration, and if acceleration is completely equivalent to gravitation as proven by the closed cage, then gravitation must also warp space and time, just like the rotating disk.
This means every single massive body in the universe, the Earth, the Sun, a distant galaxy, creates a warped, non-Euclidean field of space-time around it.
That logical bridge is the foundation of general relativity. Gravitation is not localized to the surface of a planet. It acts at a massive distance. Therefore, every physical body is surrounded by an expansive gravitational field.
Because gravitation is equivalent to the acceleration that warped the disk, we must conclude that physical events taking place within this massive gravitational field do not adhere to the old Newtonian laws of uniform time and perfectly flat, homogeneous space.
The events take place in curves.
Exactly. If a comet falls through the solar system, or if a ray of starlight passes near the sun, it will not travel in a perfectly straight Euclidean line. It is compelled to follow the nearest curve of the warped space. It follows the fundamental structural curves of the space-time universe.
We have to emphasize how radical a departure this is from the physics that dominated the previous 2 centuries. Under the Newtonian paradigm, gravity was conceived as a mysterious, invisible, attractive force, acting instantaneously across millions of miles of empty space, somehow pulling objects toward each other.
Smuts is articulating the realization that gravity is not a force pulling on objects at all. Gravity is simply the actual physical curves of the real space-time world.
He uses the specific word stratification to describe the nature of this continuum. What does stratification imply about the universe?
The term stratification is a powerful geological metaphor deployed to combat the idea of emptiness. It implies that the universe is not a featureless, empty container waiting to be filled.
It is intrinsically layered, structured, and profoundly differentiated by the presence of matter and energy.
Smuts is arguing that our entire metaphysical conception of the universe must be reoriented. We can no longer view reality as material bodies floating passively in an infinite uniform void.
Instead, we must understand that vast masses of matter actively generate and develop immense structural fields around themselves.
This makes the concept of the field the paramount idea of the text. The field extends millions of miles beyond the sensible, tangible matter itself. The field is the curved, differentiated structure of real space-time.
If gravity is not a physical rope pulling things, but rather just the geometrical shape of the field, it raises a very natural objection. Does that mean gravity is just a mathematical illusion?
That's a fair question.
If it's just geometry, just numbers on a chalkboard describing curves, does it lose its physical reality?
Smuts anticipates that exact skeptical pushback. He insists unequivocally that identifying gravity with geometry does not render gravitation an unreality, nor does it reduce it to the subjective vagaries of human mathematics.
He explicitly states in the text that these field lines are not mere empty form.
He writes, and this is crucial, that they are not mere curves of beauty, they are real and causal.
They possess the causal authority to determine the inevitable physical paths which all events in the universe must follow.
He locates the inmost fundamental nature of the universe not in static matter, but in active energy or action. It is the continuous dynamic interplay of this active energy that results in the geometric structural curves of the field.
Therefore, the mathematical structure is not an illusion. The structure itself is causally operative.
Having established this fluid structural reality, Smuts needs to position it against the historical giants of philosophy. He constructs a fascinating epistemological triad, comparing Einstein's synthesis to the three classical frameworks that defined European thought.
Isaac Newton, Immanuel Kant, and Gottfried Wilhelm Leibniz.
Mapping this out clarifies exactly what Smuts believes Einstein achieved. Let's start with Newton's baseline.
This triad is Smuts's most sophisticated philosophical positioning in the chapter. He begins with Isaac Newton, whose framework built the industrial world.
For Newton, space and time were absolute objective realities. They were invariable, permanent characteristics of the universe that existed completely independent of the human mind or any observer.
Newtonian space was infinite, homogeneous, perfectly flat, and strictly Euclidean. It was the eternal, unchanging stage upon which the material universe acted.
Then we have Kant, who essentially inverted Newton's premise while keeping the geometry the same.
Kant agreed with Newton that space and time were mathematically homogeneous and Euclidean.
But he completely denied that they were objective properties of the external universe. For Kant, space and time were entirely subjective.
They were the necessary mental preconditions, the forms of intuition, that the human mind forcibly imposes on all sensory data in order to make sense of the world.
To complete the triad, Smuts includes Leibniz. Leibniz rejected Newton's idea of space as a massive empty container. Instead, he viewed space and time as a pre-established, permanent, universal order of relations.
An order of coexistence and succession among actual things.
What Smuts argues is that Einstein's theory of relativity successfully cuts through and reconciles all three of these competing classical frameworks. In relativity, space and time are understood as conjoint coordinate forms that simultaneously belong to the subjective mind and to the objective physical reality.
How does Einstein manage to separate the subjective from the objective? How can space and time belong to both the mind and the universe simultaneously without being a contradiction?
Einstein achieved this by mathematically separating the subjective appearance of a measurement from the underlying objective reality of the event.
The specific, localized measurements of space and time, for example, determining the exact length of a steel rod or the precise duration between the ticks of a clock, are entirely relative and variable.
As we saw with the train and the disk, those measurements depend entirely on the specific state of motion of the observing mind taking the measurement. That variability is the subjective contribution to reality.
However, Einstein demonstrated that the space-time interval, the unified four-dimensional structural distance between two events, is absolutely invariant and permanent for all observers.
Regardless of how fast they are moving, that invariant structural interval is the objective reality of the physical universe. Einstein successfully isolated the subjective variable coordinate measurements from the permanent objective structural reality of the field.
Smuts views this distinction as a massive victory for realism. He emphasizes this as a realist reclamation of reality. He insists that space and time are no longer metaphysical abstractions or vague Kantian forms of intuition.
He writes that they are given elements just as color, weight, and the rest. They are concrete structural data of our daily experience.
Smuts is aggressively grounding Einstein's physics in a direct philosophical realism.
The classical concepts of infinite, perfectly homogeneous space and time championed by Kant and Leibniz are definitively dismissed by Einstein as mere limiting pseudo-concepts.
They are exposed as metaphysical abstractions that possess absolutely no relation to our actual physical experience of a universe filled with matter and energy.
Smuts drives this point home with one final thought experiment regarding the concept of empty space. He asks the reader to imagine what the situation would be if we could travel far beyond the material universe, out beyond the reach of all gravitational fields, to a place where there is absolutely no matter and no motion.
He acknowledges that in such an impossible hypothetical void, space-time would indeed cease to be curved. It would theoretically revert to being homogeneous, continuous, and exactly the form of empty nothingness.
The phrase empty nothingness is wielded as a devastating critique of the classical worldview. Smuts is arguing that a perfectly flat, homogeneous Euclidean space does not actually exist anywhere within our material universe.
Precisely because our universe is thoroughly populated with matter and active energy that constantly generate curved structural fields.
The old idea of homogeneous Euclidean space is merely a limiting conception of human thought. He calls it an astral abstraction. It corresponds to nothing physically real. The actual existing space-time continuum of our universe possesses a definite non-Euclidean structure of its own.
That brings us to the ultimate philosophical culmination of the pristine 1926 text. Smuts has systematically proven that the physical universe is fundamentally defined by structure, by real, differentiated, causal structure.
This is the foundation upon which he intends to build his theory of biological holism.
However, as we noted at the beginning, our mission today is not just to read the 1926 text, but to examine how that text evolved. The physical book, Holism and Evolution, did not remain frozen in time.
Smuts heavily revised it in 1927, just 1 year later, and again in 1936. Moving into this 20% of our deep dive, tracking these revisions reveals the fascinating, sometimes painful textual mechanics of a philosopher navigating the pressures of the scientific establishment.
The textual history of Chapter 2 is a remarkable historical document in its own right. It captures Smuts in the act of managing the deep tension between his sweeping philosophical ambitions and the increasingly rigid boundaries of specialized institutional science.
The 1927 edition, which was rushed into print following the immediate widespread public reception of the first edition, displays the very first subtle symptoms of intellectual accommodation and retreat.
Let's examine a highly specific, microscopic shift in the 1927 text. In the original 1926 baseline, while discussing the possibility that the complex mathematical equations of relativity might ultimately prove to be temporary scaffolding rather than final truth, Smuts boldly asserted his critical authority.
He wrote, "I must frankly state my own opinion."
But if you look at the 1927 Variorum, he alters that exact sentence to read, "I must frankly state my own lay impression."
That seemingly minor single-word substitution changing opinion to lay impression represents a critical moment of psychological and intellectual retreat.
In 1926, Smuts writes with the confidence of a co-equal philosophical critic. He is claiming the sovereign right of philosophy to interpret and even critique the conceptual foundations of theoretical physics.
By downgrading his stance to a lay impression merely 12 months later, he is actively abdicating that position of authority. He adopts a posture of deference and humility toward the specialist guild of mathematical physicists.
It reads as a quiet apology for having dared to offer a conceptual critique in the first place.
Additionally, the 1927 edition introduces numerous subheadings throughout the chapter, such as Newton's and Kant's ideas of space and time compared with those of Einstein.
While these subheadings are undeniably helpful for a student, they signal a growing anxiety about the density and accessibility of the text.
The insertion of these breaks subtly shifts the chapter away from a sweeping, continuous philosophical deduction and pushes it toward the more conventional, segmented format of a university guidebook.
If the 1927 revisions were subtle accommodations in tone, the revisions made in the 1936 edition are structural and severe.
By 1936, the landscape of physics had transformed. Quantum mechanics had fully solidified, and the theoretical physics community was moving at breakneck speed.
Smuts attempts some technical tightening to keep the book relevant, but this tightening results in a massive, unintended conceptual retreat regarding the core nature of relativity.
The 1936 revisions demonstrate the danger of trying to update philosophy with transient physical data. In the original 1926 text, Smuts introduced the phenomena of length contraction and time dilation as general, universal facts of relative motion.
He stated plainly that to a moving observer, a moving body appears to contract. It was a fluid property applicable to the universe at large.
But in 1936, he feels compelled to add heavy, restrictive physical qualifiers. He alters the text to mandate that these relativistic effects only occur to bodies moving with a velocity of the order of light.
He explicitly restricts the variability of our measuring standards strictly to extreme environments where observers are operating at velocities approaching light speed.
Right.
But hold on. If we pause and consider the architectural purpose of this chapter within the broader book, this restriction creates a massive problem.
It absolutely does.
The entire philosophical point of Chapter 2 was to establish that the rigid, fixed concepts of the Victorian universe had to be replaced by fluid, structural concepts in order to provide a suitable environment for biological evolution.
Yes.
If Smuts now restricts this structural fluidity, this bending of space and time, exclusively to extreme cosmic speeds, doesn't he completely undermine his own biological argument?
That observation strikes at the very heart of the tragedy of the 1936 edition.
Biological evolution, the development of cells and organisms, happens at normal, incredibly slow terrestrial speeds. If relativity only matters near the speed of light, aren't earthly organisms basically just stuck back in the flat, rigid, uniform Newtonian space he just spent 20 pages trying to destroy?
That is a brilliant catch. Scientifically speaking, Smuts was pressured to make this correction to remain accurate within the physics community of the time. At our slow, daily terrestrial speeds, relativistic length contraction is mathematically negligible.
It is practically non-existent.
But philosophically, as you have correctly identified, making that scientific concession results in a profound conceptual retreat. By cordoning off the fluidity and structural creativity of space-time to the exotic, untouchable limits of light speed, Smuts accidentally neutralizes the immediate practical utility of modern physics for his theory of biological holism.
If spacetime is only visibly curved and dynamic at the macroscopic scale of star streams or the velocity of photons, then for the terrestrial biologist peering through a microscope at a dividing cell, rigid Newtonian space remains practically unchallenged.
The physics becomes far too specialized, far too extreme, to serve as the everyday local medium for organic evolution.
It seems like he sacrificed his philosophical foundation to appease the physicists. However, the 1936 edition is not entirely a story of retreat and concession. Amidst those qualifiers, there's one incredibly bold addition.
Yes, he inserts a massive interpolation into paragraph 18 that achieves what we might call ultimate ontological purification.
The interpolation in paragraph 18 is perhaps the most philosophically aggressive statement in the entire tri-edition history. While he retreated on the practical scale of relativistic effects, he aggressively doubled down on the fundamental geometric nature of reality.
In 1936, he inserts this defining, clarifying paragraph. Where bodies seem to be moving under the influence or compulsion of forces, they're really only following the curves of the gravitational field, and the forces are purely imaginary. There are no forces in the real world, but events move freely along lines of curvature, which are the lines of least resistance.
The forces are purely imaginary. That phrase alone completely obliterates any lingering remnants of the Newtonian dualism between force and matter.
He is saying there is no invisible force pulling anything, anywhere. There's absolutely nothing but geometry.
It is the absolute pinnacle of his geometrical monism. Smuts is arguing that bodies do not require a pull or a push to move.
They simply move freely and naturally along lines of least resistance dictated by the curved structure of the field. Classical Newtonian mechanics always interpreted gravity as a pulling compulsion, implying a resistance that had to be overcome.
But Smuts clarifies that in reality there is no compulsion whatsoever, because there is no resistance to overcome. A body in free fall, whether it is an apple dropping from a branch or a planet orbiting a star, is simply traversing the straightest possible mathematical path, known as a geodesic, through a fundamentally curved medium.
The invisible forces that we feel and measure are merely imaginary, practical constructs that the human mind invents to explain away why these straight paths appear curved when we stubbornly view them through our outdated, flat Euclidean assumptions.
When we step back and survey the overarching logical progression we have navigated today, the trajectory is monumental. We started in the ruins of the Victorian era, observing the breakdown of fixed concepts.
The realization that the rigid atom and the immutable species were illusions belonging in the limbo of the obsolete.
We moved through the startling revelations of special relativity, where the illusion of absolute rest was shattered, and space and time were forced into an inseparable four-dimensional continuum just to protect the speed of light.
We then accelerated into general relativity, discovering the profound equivalence between acceleration and gravitation.
Which ultimately proved that gravity is not an invisible force, but rather the actual physical, non-Euclidean curvature of spacetime itself.
And this extensive conceptual journey inevitably leads to the ultimate conclusion of Chapter 2. Structure, specifically real, differentiated, causal structure, is the inmost fundamental form of the real spacetime world.
Through his rigorous engagement with the theoretical physics of his time, Smuts proves that the universe is not substantial. It is essentially structural.
Reality is not constructed from isolated, rigid, eternal particles being pushed and pulled by mysterious invisible forces. Reality is an active, continuous field of energy, where the inherent geometry of the structure dictates the inevitable paths of all physical events.
And what makes his deep dive so compelling is that we track this evolution not merely through abstract philosophical arguments, but through the literal evolution of the ink on the page. We witnessed Smuts navigating the intense dialectic between his holistic philosophical vision and the rigid demands of the scientific establishment over a 10-year period.
We saw him soften his rhetorical authority in 1927, awkwardly retreat on the physical scale of relativity in 1936, but ultimately drive a stake into the ground to achieve a pure, unadulterated geometrical monism where forces are entirely imaginary.
It serves as a powerful demonstration that a philosophical text like Holism and Evolution is a living, breathing instrument. The textual adjustments Smuts meticulously made across those 3 editions perfectly reflect the deep ongoing struggle of the 20th century mind.
The desire to construct a unified, holistic, philosophical framework while simultaneously accommodating the strict, advancing, and often alienating boundaries of specialized mathematical science.
We want to leave you with a final, provocative thought to mull over as we conclude this deep dive into the architecture of reality. We have established that the physical universe is not a collection of isolated objects pushed around by invisible forces, but rather a continuous active field where structure is the ultimate causal reality. Objects merely move freely along the lines of least resistance within that structure.
If that is true for the physical universe, how does this paradigm change the way you view the invisible field of your own mind?
If the material world operates entirely without imaginary forces, simply following the inherent curves of space-time, does human consciousness, with all its thoughts and decisions, also silently follow its own invisible structural lines of least resistance? It is a question that completely reorients how we perceive our place within the continuum. Thank you for joining us on this deep dive.